this unit, we've been looking at multiplying algebraic expressions or expanding. And with multiplying, it's a little bit easier. We're a little bit more comfortable with it. But today, what you noticed in the warm-up is we're moving into dividing. So I was asking you to find the greatest common factor, or the GCF, between two terms. So in the first example, it's just numbers. I have the number 3 and the number 12, and I'm asking for the greatest common factor. So the biggest number that divides 3 and 12. So if I think about that, numbers that divide 3 are just 3 and 1. Numbers that divide 12, well, I can divide 12 by 12, 6, 4, 3, 2, and 1. So the biggest number that those two lists have in common is 3. And so I could write out those lists if I wanted. Divisors of 3 are 3 and 1. Divisors of 12 are 12, 6, 4, 3, 2, and 1. And the biggest number that they both have in common is 3. So the GCF here is 3. When I look at part B, now I'm starting to add in some algebra. So now I want the greatest common factor, or the biggest number that divides 18 and 24x. So first I'm going to ignore the x and just look at the coefficients, or the numbers. And I'm looking for the biggest number that divides both 18 and 24. So when I think through those lists, the biggest number that divides 18 and 24 is 6. And then I ask myself, what's the biggest number of x's that I can divide both terms by? Now the 24x, I can divide that by x, because there is at least one x there. But the 18 does not have any x's, so I can't divide it by x. So my greatest common factor is 6. For the last example, I'm adding in a bit more algebra. So both terms now have some x's. So first I'm going to just again look at the numbers 27 and 72. And I'm going to ask myself, what's the biggest number that divides both of those? Now, I notice that I can divide both of those numbers by 3, but I think there might be something even bigger. So when I think about the number 27, I know that I can divide that by 27. Of course, I can always divide it by itself. I can divide it by 9, I can divide it by 3, and I can divide it by 1. When I look at 72, there's lots and lots of numbers that I can divide 72 by, but I'm looking for the biggest one that I've already listed. So I know that 27 does not divide evenly into 72, but 9 does. So 9 is actually the biggest number on that list that is also going to appear on the 72 list. So 9 is the number part of my greatest common factor. Now I need to figure out how many x's can I divide both terms by. Well, the first term has 2 x's being multiplied. That's why it says x squared. And the second term has 1 x being multiplied by it. So there's just x to the power of 1. So I can divide both of those by at least 1x. I can divide the first term by 2 x's, but I can't divide the second term by 2 x's. So the biggest number of x's I can divide by is 1x. So my greatest common factor there is 9x. So to find factors, the operation that I'm using is dividing. And I mentioned this briefly yesterday. When we're talking about algebra, instead of using the word dividing, we use the word factoring. When I factor something, it means change it so that it looks like multiplication. So I could think about, if I wanted to factor, say, the number 12, I could factor it by writing it as 6 times 2. That would be the factored version of 12. So what we're going to do here in the first example is change 2x squared plus 6x so that it looks like something times something. That's our goal. So on the right-hand side here, I see that my first step is to find the GCF, or the greatest common factor, of both the terms. So I'm looking for the biggest number that divides 2x squared and 6. So first I look at the numbers, 2 and 6, and I'm asking myself, what's the biggest thing that divides 2 and 6? And the biggest number that's going to divide both of those is 2. And then I'm looking at, well, how many x's are there? Well, in the first term there were 2 x's being multiplied, and in the second term there was 1 x being multiplied. So the biggest number of x's that I can divide by is 1x. So my greatest common factor altogether is 2x. Step 2 is the one that a lot of people forget when they're actually writing down their solution. It's important that you include the greatest common factor in your solution. So when I put my equal sign to say 2x squared plus 6x is the same as, it's going to be 2x, and then I'm going to multiply by the leftovers. What happens when I divide everything by 2x? So I'm going to put the leftovers into a set of brackets, and I'm going to divide each term by the GCF. So I'm going to take a look first at the first term, 2x squared, and I'm going to divide it by the 2x that I came up with. Well, first I'll look at the numbers. So I've got 2 divided by 2, and that gives me 1. And then I'm going to look at the x's. So here in the original, I've got an x squared, and then here in my greatest common factor, I've got 1x. So I've got x squared divided by x. And if you remember back from last week, to divide, we subtract the exponents. So x to the 2, x to the 1, 2 minus 1 gives me 1x. Next, I'm going to divide the second term, 6x, positive 6x, by the 2x again. So first I look at the number, positive 6, and I divide it by that 2 out front. Positive 6 divided by positive 2 gives me a 3. And then I look at the x's. So I've got 6x, which is 1x there, and then I've got another x here. And if I'm dividing them out, they're going to cancel each other out. X divided by x is just 1, and so I'm done there. So I've got my final answer. If I wanted to clean it up, I can get rid of a couple of those ones, and I can just say 2x times x plus 3. So that is the end of that question. That's as simple as it can get. If I wanted to check my answer, though, what I could do is multiply it back out by distributing the 2x into the bracket. When I do that, first I would do 2x times the x, the first term in the bracket, and that would give me 2x squared. And then I would do the 2x times the 3 in the bracket, and that would give me positive 6x. And as you can see, that's the original question that I started with, so I know that I did the question correctly.